Hi, today we are going to study about energy. Energy is the quantitative property that is transferred to a body or to a physical system, recognizable in the performance of work and in the form of heat and light. Energy is a conserved quantity. The law of conservation of energy states that energy can be converted in form, but not created or destroyed. The unit of measurement for energy in the International System of Units, C, is the joule, defined as the energy transferred to an object by the work of moving it a distance of 1 meter against the force of 1 Newton. Common forms of energy include the kinetic energy of a moving object, the potential energy stored by an object, for instance due to its position in a field, the elastic energy stored in a solid object, chemical energy associated with chemical reactions, the radiant energy carried by electromagnetic radiation, and the internal energy contained within a thermodynamic system. All living organisms constantly take in and release energy. Due to mass-energy equivalence, any object that has mass when stationary, called rest mass, also has an equivalent amount of energy, whose form is called rest energy, and any additional energy, of any form, acquired by the object above that rest energy will increase the object's total mass just as it increases its total energy. Human civilization requires energy to function, which it gets from energy resources such as fossil fuels, nuclear fuel, or renewable energy. The Earth's climates and ecosystems have processes that are driven either by the energy the planet receives from the sun or by geothermal energy. The fact that energy can be neither created nor destroyed is called the law of conservation of energy. In the form of the first law of thermodynamics, this states that a closed system's energy is constant unless energy is transferred in or out as work or heat, and that no energy is lost in transfer. The total inflow of energy into a system must equal the total outflow of energy from the system, plus the change in the energy contained within the system. Whenever one measures or calculates the total energy of a system of particles whose interactions do not depend explicitly on time, it is found that the total energy of the system always remains constant. While heat can always be fully converted into work in a reversible isothermal expansion of an ideal gas, for cyclic processes of practical interest in heat engines, the second law of thermodynamics states that the system doing work always loses some energy as waste heat. This creates a limit to the amount of heat energy that can do work in a cyclic process, a limit called the available energy. Mechanical and other forms of energy can be transformed in the other direction into thermal energy without such limitations. The total energy of a system can be calculated by adding up all forms of energy in the system. Energy exists in many different forms. Examples of these are light energy, heat energy, mechanical energy, gravitational energy, electrical energy, sound energy, chemical energy, nuclear or atomic energy, and so on. Each form can be converted or changed into the other forms. Although there are many specific types of energy, the two major forms are kinetic energy and potential energy. Kinetic energy is the energy in moving objects or mass. Examples include mechanical energy, electrical energy, etc. Potential energy is any form of energy that has stored potential that can be put to future use. Examples include nuclear energy, chemical energy, etc. Chemical energy is energy stored in the bonds of chemical compounds, atoms, and molecules. Chemical energy is released in a chemical reaction, often in the form of heat. For example, we use the chemical energy in fuels like wood, coal by burning them. Electrical energy is the energy carried by moving electrons in an electric conductor. It is one of the most common and useful forms of energy. Example, lightning. Other forms of energy are also converted to electrical energy. For example, power plants convert chemical energy stored in fuels like coal into electricity through various changes in its form. Mechanical energy is the energy a substance or system has because of its motion. For example, machines use mechanical energy to do work. Thermal energy is the energy a substance or system has related to its temperature, that is, the energy of moving or vibrating molecules. For example, we use the solar radiation to cook food. Nuclear energy is the energy that is trapped inside each atom. Nuclear energy can be produced either by the fusion, combining atoms, or fission, splitting of atoms, process. The fission process is the widely used method. Uranium is the key raw material. Uranium is mined from many places around the world. It is processed to get enriched uranium, that is the radioactive isotope, into tiny pellets. These pellets are loaded into long rods that are put into the power plant's reactor. Inside the reactor of an atomic power plant, uranium atoms are split apart in controlled chain reaction. Other fissile material includes plutonium and thorium. At a chain reaction, particles released by the splitting of the atoms strike other uranium atoms and split them. The particles released by this further split other atoms in the chain process. In nuclear power plants, control rods are used to keep the splitting regulated, so that it does not occur too fast. These are called moderators. The chain reaction gives off heat energy. This heat energy is used to boil heavy water in the core of the reactor. So, instead of burning a fuel, nuclear power plants use the energy released by the chain reaction to change the energy of atoms into heat energy. The heavy water from around the nuclear core is sent to another section of the power plant. Here it heats another set of pipes filled with water to make steam. The steam in the second set of pipes rotates a turbine to generate electricity. There are 35 countries including India in the world which generate electricity from nuclear source. According to the data published in March 2017, by Power Reactor Information System (PRIS) of International Atomic Energy Agency (IAEA), India is ranked at 13th position in terms of power generation. However, it stood at 7th position in terms of number of reactors in operation country-wise, globally. The current installed nuclear power capacity is 6,780 MWe. At present there are 22 nuclear power reactors. The installed capacity is expected to increase gradually to 22,480 MW, including PFBR, 500 MW being implemented by Bharatiya Nabhikya Vidyut Nigam Limited (Bhavini) by 2031 on progressive completion of projects under construction and accorded administrative approval and financial sanction by the Government of India. The average tariff of nuclear power in the financial year 2016-17 was Rs 2.95 per unit. Gravitational energy is that energy held by an object in a gravitational field. Examples include water flowing down a waterfall. Thanks, we will meet with next topic.